right, so welcome everyone to our fourth workshop on AI and academic research. Today I'm joined by Drs. Colleen Cheverko and Dr. Adam Wilson for an exploration of AI deep research systems and reasoning models for academic research. If you missed any of the previous workshops, please feel free to reach out to me and I'd be happy to send you a link to the recording. All right, so by the end of today's workshop, you'll be able to do the following. Summarize key capabilities of AI agents with deep research tools relevant to academic research, identify practical applications in literature review, document analysis, and information-seeking activities. And finally, you'll be able to identify opportunities and limitations for applying these AI systems. Here's sort of the high-level overview of the topics that we plan to cover today. We'll be starting off with a current state of recent AI developments. And from there, we'll turn to some of the deep research promises that we'll explore and test in today's session. And we'll follow that up with 3 mini experiments, the first touching upon literature reviews. The second will address web scraping, synthesis, and reporting. And finally, we'll look at qualitative research and thematic analysis. And then we'll round out things with a discussion of perils, challenges, and limitations. Hopefully I can speak for all of the presenters today in that we welcome questions, or feel free to interject and put things in the chat along the way, and we'll make sure that there's time for questions at the end, or at least we'll do our best to do that. All right, so before we really turn to our mini experiments, we just wanted to take a few minutes today to talk about the current state of AI, which of course, as we know, is moving rather quickly. So in terms of where we are today and how we got here, a little bit of context. In recent months, we've seen an uptake in what are called reasoning models as AI tools or systems. And so these are AI systems that can execute complex tasks. As a roughly parallel development to these AI reasoning models, we also have seen a movement towards more autonomous AI systems. Some of these are Claude's computer use and ChatGPT operator, both of which emerged in fall 2024. Now, if you're not familiar with these phenomenon, it's not a big deal. Suffice it to say that these early, what we might call agents, were somewhat rudimentary. They were sort of clunky. They would move around websites and they could accomplish tasks, but they weren't necessarily optimal. What we're seeing now is the emergence of AI agents that can more smoothly navigate and click on websites, complete CAPTCHAs, and much more, as we'll show later today. So essentially what this represents is the movement from very narrow task-specific AI agents that could do things like look at a website and create an Excel sheet to doing a wider range of tasks more independently. Now, before we move on, I'm just going to say a little bit more about reasoning models and AI agents. So just a little bit more about AI agents, reasoning models. Reasoning models are a specific, we might call them a class of AI systems. Some of them you've probably heard of, like ChatGPT 01 or 03, or there was a lot of buzz around DeepSeek. So these are AI models that will break tasks into logical and more discrete aspects or tasks, I guess, while verifying answers along the way. Now, some of the reasons that these models are particularly effective is that they're said to do things like stimulate human thinking. They do this by revisiting and refining its responses and sometimes altering course, depending on what it finds. They work by applying something called chain of thought reasoning. And so we could think of this as a model being trained to sort of think out loud, or if we're thinking about math, it's required to show its steps in completing an equation. So the goal of these models is to produce clearer and more accurate answers. And so in showing its reasoning through something called reasoning traces, AI decisions may become more transparent and easier to understand. At the same time, these models actually work a little bit more slowly than previous AI models because of the complexity of the tasks they can now accomplish. Sort of the other side of the coin for our conversation today are these deep research systems. And I suggest that we might think of deep research systems as just a subset of AI agents. So these are systems designed to assist with research tasks. A couple of examples include OpenAI, Gemini, and Perplexity. And as we'll hear a little bit more, these systems work by being prompted to complete independent tasks relating to different research elements, doing things like searching and synthesizing or locating documents and generating reports. Now, of course, it's AI, so it gets more complex than just those aspects that I've outlined. And so what I want to do before we move on is just show what the future of these AI agents might entail, specifically with regard to academic research. And first, I'm going to do this by introducing a domain-specific AI system called Sakana's AI Scientist. This was a system that was released in August 2024 for the field of machine learning. Now, what's intriguing about this is it's a domain-specific multi-agent system. So it's not just one AI agent, it's a whole range of them working together to complete a range of tasks. This particular multi-agent AI system was designed to help researchers in the field of machine learning do things like generate hypotheses, perform experiments, write code, and summarize the results. And just last month, a paper that was generated by this system passed the peer review process at a top machine learning conference. So I think that's pretty exciting in terms of thinking about the possibilities and the pitfalls, as we'll talk about later, of these AI agent systems. In terms of future-looking technology, another possibility that is out in the open already is Google's Co-Scientist. So like Sakana's product, it is a multi-agent system built on the Gemini 2.0 platform. And this one is more domain agnostic than Sakana. So it's designed to assist scientists in doing things like generating hypotheses and developing a research plan. What makes it different from Sakana is it's not intended to entirely do the research or research across an entire life cycle. It's just supposed to assist in specific areas. Now, this product is currently available for limited testing, so you have to complete a request form and try to get access. So it's not widely available yet, right? So that was just a glimpse of some of the directions in which AI agents might impact academic research. What I want to do now is hand over the conversation to Adam, who's going to tell us a little bit more about these deep research systems and specific applications.
Hello, everyone, and thanks again for attending. While it might be fun to think about the future of AI and what it might look like, part of my job is to sort of bring us back down to reality a little bit to help you better understand what current capabilities are. So these newer multi-agent systems, in my mind, are really early precursors that could eventually give rise to automated research. So for example, there may soon come a time when multi-agent systems could conduct systematic reviews and meta-analyses from start to finish. Spoiler alert, we're not there yet, but things are progressing toward that type of automation. So part of the goal of this workshop is to help you tease apart AI's future potential from its current capabilities. And the only way for us to separate fact from fiction is to really put these deep research models to the test. So we're going to do just that. Next slide, please. And so for the remainder of this presentation, we'll share the outcomes from a series of mini experiments where we utilized deep research models to accomplish a series of different research tasks. These practical use cases in both research and education will hopefully give you a glimpse of the technology's current capabilities. Now, just to reiterate, unlike prior AI models, again, the deep research models are supposed to excel at these multi-step processes. Therefore, because of that, we decided in our mini experiments that we were going to test how well these deep research models could conduct multi-step research processes from a single prompt. So let me go ahead and set up the first experiment for you, and we'll walk through what we've done here. Next slide, please. So even though we piloted the use of AI for conducting literature reviews in our prior workshops, we wanted to circle back to this particular topic to see whether or not deep research models have really made strides and improvements over other models. In our previous testing, we found that AI systems were returning fake citations and using open source literature, and these systems had difficulty handling multi-step requests in a single prompt. These are things I'm sure you're hearing yourselves from the general literature and from the news for that matter. And so for this mini experiment, we wanted to use the deep research models to draft the introduction section of a manuscript. And so we were hopeful to see a robust narrative and sound arguments and real citations from the deep research model. And we wanted the writing to be, of course, of high quality, and we wanted the writing to have clear elements of synthesis and integration. So in essence, we wanted the deep research model to be able to execute a 4-step process. We wanted the systems to search the literature, to synthesize the literature, to craft useful arguments with a robust narrative, and of course, we wanted the system to return usable citations for the purposes of a bibliography. And we wanted all of these AI systems that we tested to accomplish these tasks with a single prompt. Next slide. So for this first mini experiment, I wanted the deep research model to write an introduction about using AI to score the quality of medical education research studies with something called the Mirsky rubric. Mirsky stands for Medical Education Research Study Quality Instrument, and it is a tool that's commonly employed in medical education research to judge the quality of the research product. And so for this experiment, we investigated 3 different systems, actually 5. So we looked at OpenAI's deep research model, and then we looked at multiple versions of Gemini's deep research model. And then lastly, we also looked at Perplexity. Next. So here is the elaborate prompt that I wrote outlining all of the details to include in the introduction. So in pink font here, I'm simply drawing your attention to some of the key elements that I wanted in the output. For example, at the end of the first paragraph, notice that I wanted the introduction to follow the problem, gap, hook approach. If you look at the second to last paragraph, I wanted to highlight the research gaps in the literature, and I wanted to demonstrate a clear need for validity evidence. And then in the last paragraph, I wanted the introduction to introduce, of course, the research question and to also highlight the significance of the work. And I've also given it kind of the starting question that I wanted it to consider as it was writing its draft of the output. So overall, for this prompt, I was very explicit with the topics that I wanted to be included, that I wanted the system to write about. And I also provided very specific instructions for the flow of the narrative. And so when it was time to test the AI systems, we took this entire prompt and we fed it into each of the deep research models. Next. To provide you with some tangible outcomes, we conducted an informal comparison of the deep research systems by exploring 3 different domains of interest. We looked at the writing quality, so the depth of insights in the content. We also looked at how well each model conducted the tasks and followed through with the task that it was assigned. And then lastly, we looked at citation quality. Next. All right, so here is a table that shows the 5 deep research systems that we piloted. Notice the last 3 are all different versions of Gemini. So the green font here means that I was pleased with the outcome. For example, the writing outputs across all the systems were usable and they were relevant to the topics that I wanted. So the writing was actually quite good, which isn't of a lot of surprise because I'm sure you've experienced that yourselves in the systems that you've used. The yellow font means that the outcome could have been better, and then the red font means that the outcome was significantly lacking, in my opinion. So in general, all of the AI systems returned usable and believable content, and most of the systems gave me all 5 paragraphs that I wanted with the relevant content in each paragraph. Now, unfortunately, when it comes to citations, the citations that were returned were still very problematic. In a 5-paragraph introduction, which is what I asked for, I would expect to see around 15 citations. That's about 3 citations per paragraph, right? It's just sort of a general rule of thumb that I sort of use. Well, per these outcomes, the first 3 systems returned 6 or fewer citations. And of those returned citations, several were unusable. And what I consider to be an unusable citation meant that it was either a hallucination where it didn't return a real citation, or it came from a non-reputable source, or maybe it was a conference proceeding. So all of those are what I consider to be unusable citations. And then lastly, I'll point out just briefly that many of the AI-specific citations were actually quite old. So notice how the Gemini systems, which return the most citations, stopped at 2023. So in other words, the 2-year-old citations for AI topics that it returned were, of course, a bit problematic because they're older than really what I wanted to use. When it comes to citing AI, you want to use, of course, the earliest, most recent evidence, which would be either from 2024 and or from 2025. So it was a little disheartening to see that there were these hard stops at 2023 for the Gemini systems. So did the deep research models handle the multi-step task that was written as a single prompt? I guess you could say yes, technically it was able to handle the task, but of course, as we can see from this table, there is still a lot of room for improvement. I think it's also worth mentioning that Gemini has undergone further updates since the time of this pilot. So for example, as of last Friday, Gemini 2.5 Pro was recently released, and that system is now available to anyone for use. All right, so given these lingering issues and limitations with the literature search process that we see here in the outcomes, I think it's safe to say that AI cannot yet autonomously draft a research manuscript. It still requires a fair amount of human oversight during the writing process and literature search and review process for that matter. Okay, so next we ask the question, how well can deep research models collect data? And to explain the outcomes of that study, I'll hand it over to Dr. Cheverko.
Thank you. Okay, so for our second mini experiment, we explored how GenAI performs as a data extraction assistant, which could be useful for things like document reviews, website analyses, etc. So our focus is on educational research projects here, but there could be similar uses across fields and topics in academia and not. So our overarching goal was to test GenAI's ability to serve as a data extractor for website reviews. And to investigate this goal, we compared the results from our mini experiment to data from a project that Adam and I just wrapped up. So we tested OpenAI ChatGPT o3 Mini High with deep research, Gemini 2.0 Flash Thinking Experimental, and Perplexity Deep Research in this mini experiment. The main steps that GenAI systems had to do, which I'll detail more as we go through the next few slides, were to comb websites linked to an Airtable or Excel document of programs, compile the data in a usable table, and perform limited data cleaning. Next slide. But first, let's talk a little bit about the background for website analyses. Data extraction for website analyses crosses fields and subjects and can be performed by groups of human extractors, by Gen AI web scraping applications, and theoretically now with Gen AI assistants. As the least technological of the three, data extraction can be performed by humans, which is very frequent in educational research studies. So as independent researchers, we can make judgment decisions when we need to, and then confirm those judgment decisions through either using the data collection guide and also the consensus process. As you can imagine, these manual extractions take a lot of time, especially when content is in different locations or it's worded differently between websites. Web scraping, which is defined as the automated extraction of website information, has big data applications across fields. Once it is coded, this method has the potential to generate a large amount of information in a much shorter period of time. But the limitations are still well documented. So for example, it's based in traditional code, so it requires some degree of coding expertise. Those codes are sensitive to changes in website layout or content type. and they are much less adaptable to variation in wording than, say, human extractors would be. So as it continues to develop, Gen AI, especially models with deep reasoning capabilities, might help address some of these limitations and challenges. But regardless of the method, each of these three types of data collection are still going to be limited by incomplete or inconsistent information across web pages that would limit the analyses that eventually can be performed on the extracted data. Next slide, thank you. Okay, so to test Gen AI deep research capabilities, we set up our second experiment to use a subsample of data that we had collected as part of a larger website review that was focused on anatomy course characteristics in PA programs in the US. Instead of using all 12 variables from all 309 program websites, we chose to run a subsample of 6 key variables for 49 program websites. In the original study, we had 2 teams of 2 reviewers, each score half of the program websites. We then had them review items in disagreement to come to a consensus value, and then Adam or I stepped in as the third reviewer if needed to firm up those consensus decisions. So our goal here was to compare the Gen AI extracted data to the human consensus values. Next. Okay, so this chart shows our variables according to difficulty levels that we assigned, and then part of the instructions provided to the Gen AI systems in the initial prompt. I will say I shortened these descriptions for presentation purposes, so you don't have the full prompt here. So we chose these 6 variables deliberately to include 3 different difficulty levels. So difficulty 1 were listed on program websites, often in very short text phrases and largely requiring no interpretation or calculation. So the example here is PA program length, which was usually listed as the PA program is X number of months or so on. Our difficulty 2 variables required some interpretation based on wording, but no calculations. So these included anatomy course format. So whether the anatomy course was independent or standalone, and it was an independent standalone course focused on anatomy, or whether it was taught combined or integrated with other subjects. And then second, for difficulty 2, the term anatomy was taught, which was defined as first term, second term, or across multiple terms. And then the third difficulty level required interpretation and calculation. And so this included length of the didactic curriculum, where the length of the didactic section often had to be separated from the clinical portion and subtracted from the total PA program length. And then also the sum of anatomy credit hours and the sum of total PA program credit hours, again, often requiring calculation. Next slide. So this shows the prompt that we fed into, or part of the prompt that we fed into all 3 systems. In writing this prompt, I really took the approach of trying to give enough information that I would give to a research assistant, but also to keep in mind the logical flow that I would need to layer a code if I were to write a code for something where the order of the code or the precise language of the code is important to obtain the desired output. So I also highlighted some key components to the prompt in pink. What I want to draw your attention to is that we provided the website links for each PA program and told the Gen AI systems to stay within the institutional website and associated links. So we didn't want them to pull from random web pages. Gemini was able to read the Airtable link. ChatGPT required us to upload it as a CSV file, and Perplexity required us to paste the information directly into the form. So even here, we ran into differences between the 3 systems that we were able to work with. Our detailed instructions for each variable were attached to the prompt as a separate data collection manual. And we did include a couple of additional variables, program name, city, town, and state, so that we could confirm which programs we're actually having data with. Our detailed instructions for each variable were, I already said that. Okay, so we asked for each system to generate a data table, which with each program representing a separate row and variables in a separate column. So in addition to our variables, we did ask the Gen AI systems to also provide a URL. And so we were able to follow that URL manually to confirm where the information was being extracted from if and when we wanted to. And I do want to point out here that even though we asked for a data table to be returned, Emily needed to transform the results using a code interpreter to get them into a usable file. Next slide. So when comparing between systems, ChatGPT o3 Mini High with deep research was able to return information for 45 of the 49 target programs, but it struggled to return information for several of the variables, which I'll outline on the next slide. What I want to highlight is compared to the roughly 6 to 8 hours minimum that it would have taken our human researchers to extract data from these 49 programs, ChatGPT's runtime was only 27. Gemini 2.0 Flash Thinking Experimental reported data for 29 of the 49 programs that we targeted. It took roughly 6 hours, so significantly longer than ChatGPT, but it reported information for all variables across the 29 programs. And in 2 slides, I'll talk about the agreement rates behind all of these variables. Gemini also returned information for an additional 13 programs, which represent false returns. So in the case of our mini experiment, excluding these false returns was very straightforward because we had the program list directly from the accrediting body that we uploaded to each of the systems. So we were able to just eliminate those extra programs as not important to our study aims or not relevant to our study aims. If we didn't already have these data to compare to, or this list from the accrediting body, this would have been much, much more difficult to exclude those false returns. And then lastly, Perplexity Deep Research only returned information for 1 of the 49 programs in less than 5 minutes. Because of this much lower program return rate, we essentially ignored Perplexity moving forward because the sample size of 1 doesn't allow us to discuss anything. Next slide. So this slide shows the breakdown of information return rates for each of the human assistants in the project, ChatGPT and Gemini. I want to highlight again that each human assistant was responsible for half of the programs in the original study, which translated into 20 programs for assistants 1 and 3 and 29 programs for assistants 2 and 4. But ChatGPT and Gemini were responsible for the full 49 programs. So here in pink, I've identified the information return rates that were lower than 50%. So all extractors were able to record information fairly successfully for difficulty 1 and 2 variables, but ChatGPT struggled to return information for 2 of the 3 difficulty 3 variables, which were anatomy credit hours and program credit hours. Unfortunately, if we were to actually use these data, these were very important variables for our big, larger study. And I do also want to point out this human 4 anatomy credit hour return rate is lower than all of the other return rates. Most of the variables across most of the human assistants had very high return rates across variables. This one individual just consistently missed this 1 variable in their initial data run, which is what we were comparing, but this was addressed through the consensus process for the actual study. Next slide. Okay, so information return rate is one thing. So how often did they collect data for each of the variables? But really the meat of our comparison should be how well did they pull information for each of the variables. So this table shows absolute accuracy rates listed. In terms of the human by consensus ratings, this is the percentage that both humans who extracted information from those programs agreed with consensus. And then for the Gen AI systems, it's simply the percentage that each Gen AI system agreed with consensus. So again, I've highlighted values under 50% in pink here. To start, let's go through highlighting Gemini's results. So despite recording information for all variables across the 29 programs that it was able to return, the percent agreement for Gemini versus consensus is under 40% for all variables. And some of these are very low. So for example, this PA program credit hours on the bottom right is at 0%. It was able to be in agreement with consensus 0 times out of the 29 that it returned, or the 49 overall, I should say. ChatGPT performed better than expected, or better than I expected that it would, for the difficulty 1 and 2 variables, ranging from 51 to 61%. But it was under 50% for all of the difficulty 3 variables. Regardless, all of these values are well under the comparisons when you consider the human by consensus % agreement across all variables. And this includes being under the % agreement for anatomy credit hours, where one of our extractors just happened to miss most of the programs. So our big take home from this comparison, or these comparisons, is that Gemini was able to extract information from all variables for a limited number of programs, but the % agreement rates are quite low. ChatGPT was more in agreement with human consensus across most variables, but again, not high enough where I would consider it to be useful for similar projects, at least at this time. So with that outlook for mini experiment 2, I will return the presentation back to Emily for the third.
All right, thank you. I'm going to talk a little bit about using AI for qualitative analysis, and in particular, thinking about AI as a coder for thematic analysis. In setting up this mini experiment, I do want to distinguish the fact that whereas Adam and Colleen used a variety of deep research tools, for my pilot mini experiment, I only used OpenAI's ChatGPT 03 Mini High because the reasoning capabilities were more relevant to this particular experiment than deep research functionality. All right, so for this mini experiment, I decided to return to a research project in progress. And the goal of this broader research project, on which I'm collaborating with Adam and several other researchers from outside of Rush as well, is to examine US medical schools' AI policies. So just a little bit of background about the project itself. A number of researchers collected AI policies from 147 medical schools, and then working in pairs in 8 teams, we used Deduce to analyze the policies in comparison to an idealized AI policy framework. And you can see sort of the skeleton for that framework on the left. So my goal for the mini experiment, and this is actually a repeat mini experiment, is to see how well AI systems can apply this idealized AI policy framework on this slide. Now, I've previously conducted this experiment in January using ChatGPT 01. You can see the prompt that I used for that version of the experiment on the left. So at that time, I gave ChatGPT 01 a detailed prompt with the most salient part of the instructions are highlighted in pink. So I asked it to assign a numerical score for each sub-theme. As you may have glimpsed on the previous slide, there are 24 sub-themes in the thematic analysis framework. I did this because initially I just tried to have AI do a thematic analysis, and at that time in January, it was unable to do that. So instead, I recalibrated and asked it to look for the prevalence of these themes in AI policies and assign a score of 0 for not mentioned, 1 for brief reference, and 2 for moderate detail, 3 for in-depth detail. As you can see from a screenshot from the Excel spreadsheet on the right, AI scored every single sub-theme as 0. So at that time in January, it was the AI tool ChatGPT 01 was completely unable to identify the prevalence of any of the framework elements in AI policies. Undeterred, I decided to try it again this month. So I'll talk a little bit about my repeat experiment in light of recent AI developments. So this time I used ChatGPT 03 Mini High. As I said, I didn't use any deep research tools. Again, the goal was to compare, well, first of all, to see if AI could apply the detailed thematic analysis framework that you saw a few slides ago, and then subsequently to compare AI coding of policies to human coding of policies. So for the mini pilot experiment, I looked at and I entered 101 AI policies into ChatGPT 03 Mini High, and I only selected policies from a very small selection of institutions, so 4 institutions out of roughly 150. From there, I asked it to apply the coding framework, and I gave it coding instructions that did not restrict it to the application of a single code, since there were many instances in which human coders also applied multiple subcodes per each excerpt. After that, I then manually compared the results between AI and human code application. All right, so this is the prompt that I use on the left with specific instructions in urging ChatGPT that it should be as granular as possible in its code application, with a suggestion it identify codes at the smallest unit that captured a complete idea. And I gave it the freedom to assign all relevant parent and child subthemes to each segment. Now, much to my surprise, the AI actually was able to accomplish this task, unlike it was able to do in January 2025. And even more exciting was the fact that my first attempt did result in an exact match. So both AI and the human identified the same passage and the exact same subthemes. Now, as I continued coding increasingly complex AI policy documents, as you can see, the agreement levels fluctuated quite a bit. So what you're seeing here is the results that reflect a collapsed agreement structure. And what I mean by that is full agreement meant that the AI and human applied the exact same code to the exact same excerpt from a policy. Whereas no agreement meant there was partial agreement in the sense that there was some code overlap. Usually AI or human and AI both identified one code, but not multiple codes in instances which multiple codes were applied. So there wasn't a full match in that case. And also, no agreement includes complete disagreement. Across the 101 policies, I found from my pilot experiment, 21.78% showed full agreement between human and AI coding. And in order to also look at reliability but beyond chance, Adam calculated Cohen's kappa, which was 0.176, which indicates slight agreement beyond chance. So it's not a high kappa, of course, but perhaps I would suggest, given the complexity of the task and that AI was coding full documents, it's reasonable for a starting point, we'll say that. And just for a rough comparison from our deduce dating set and code reconciliation tests, I looked at the human coding excerpts from the same data set from which I drew my policies, and the Cohen's kappa values were 0.56 and 0.26, showing moderate and fair agreement. So that's a rough comparison, but it's not a precise unit of comparison. All right. Now, going the wrong way. Now, despite the low level agreement, I did observe some coding behaviors and thematic emphases that I think are worth noting. And so I'm going to start with table 1 on the left in terms of coding patterns and behaviors. Now, some things that I did observe is that there was a high degree of parity in terms of how the codes were applied. And what I mean by this is humans applied 129 codes across these AI policies, and AI applied 130, and both groups used precisely 21 out of 24 subcodes. Something that stood out is that, perhaps due to my instructions, AI applied more fine-grained codes, and sometimes coded segments that were left uncoded by humans, particularly near the end of policies. What struck me also in this pilot experiment is that AI often applied a broader range of codes across consecutive segments as well. So I think that is something to consider. If we look at the right side of the slide on table 2, we see a side-by-side comparison of 6 subcodes where human and AI coders showed different thematic emphases. So as you might recall from a moment ago, I said that both groups applied 21 out of 24 codes, but they didn't always apply the same codes. So for example, the human coders used codes like educational or philosophy and compliance responsibility that AI missed, whereas the AI uniquely applied codes like reflective engagement or technical infrastructure. And so what this suggests to me is that there are possible differing interpretations of the framework between human and AI, and there might be different prioritization of different textual or contextual cues. All right, so just to wrap up my conversation or my part of my mini experiment, in terms of the preliminary interpretation, so I would say that although the direct agreement between human and AI coders was very slight, with limited overall thematic agreement that overall thematic coverage was similar. I'm going to speculate that even though I wouldn't want to hand over the job yet to AI to do this kind of detailed thematic analysis, that AI might demonstrate potential, at least for pilot testing the thematic framework or looking for overlooked themes before handing over the job to humans. If I were to continue this experiment, some next steps that I might do to streamline it and to make it a little bit more systematic are to better align the units of analysis by having AI code excerpts rather than full policies, which would be in greater agreement with what we have from deduce in the inter-rater reliability testing. I would also want to standardize coding by asking both parties or ensuring that both parties are only applying a single code to one excerpt, which perhaps served as a complicating variable. Naturally, I'd also want to include a broader sample size from greater excerpts in more institutions and a wider range of human coder samples as well. All right, so now I'm going to turn the conversation back over to Colleen, and she's going to talk a little bit about some of the limitations of this type of AI-assisted research.
Thanks. Okay, so to wrap up, I want to highlight really what I've identified as two main categories of limitations and cautions to leave you with after these three mini experiments. So first, the use of Gen AI still needs human oversight and guidance, and considerable human oversight and guidance from the results of all three of our studies. We really need to understand where data are being pulled from, when it is pulling data, and how it's being pulled. So citing sources, referring to specific text, and returning URLs should all be considered as part of the prompt process so that we can go back and see where those data are coming from. This could potentially help researchers address things like hallucinations, which we saw in Adam's literature review, false information returns like we saw in mine, and so forth. Second, for many research applications, accuracy is still lagging behind what we would consider to be usable human standards. And potentially also study replicability, though we didn't directly address study replicability in these experiments. So this combined brings another question for me, whether the need for human oversight and direction actually translates to time saved for research applications at this point. So for example, in the writing process, maybe, but it depends on the quality of the writing and the references. For something like the website extractions, it probably wouldn't have saved us much time when you count the steps of needing to verify each individual entry given the lack of percent agreement. On the right-hand side, the other kind of realm of limitations and cautions that I want to call attention to is that we need to be very well aware of our publishing standards before implementing AI into studies. So many major publishing outlets at this point allow for AI-assisted writing, but they also highlight how it should be used as an aid and not a replacement. So authors under these guidelines still need to insert their own voices, their own ideas, and take full responsibility for their content, whether it's AI assisted or not. Similarly, some publishing outlets, or at least some publishing outlets, restrict the use of AI for independent or sole data collection purposes. So we need to be aware of those restrictions. One example, this is from a couple of weeks ago, but Wiley has in their current author guidelines the quote that Gen AI tools cannot be used to create, alter, or manipulate original research data and results. So at this point in time, our publishing standards largely don't allow for independent data analysis. But as Gen AI systems improve and continue to develop, there may come a time where that changes. So if you're in doubt, I'd say look at those publishing standards before proceeding. And then last, Gen AI is still rapidly developing. So as Emily showed in her mini experiment, what wasn't possible in January was now possible in April. And so we need to continuously reassess AI capabilities to understand current potentials, current limitations, and current publishing standards, as these are all likely to change and potentially change rapidly as we go. So with that, I think Emily is next.
I think we actually have a few minutes for questions if you're both okay with that.
Yeah.
All right. So yeah, we can open up the field for questions for a few minutes before we wrap up. Adam, I think there was a question earlier in the chat about, I think it was specifically in reference to your portion about the types of references and did they appear to be primarily open source, open access resources?
Yeah, so it would seem that that is still the case, whereby the deep research models were pulling from either open access resources and or we're just taking abstracts and summarizing data from those abstracts to generate its content. So it would still seem that there are some paywall or firewall types of barriers whereby these deep models are not yet able to access some of the journals, for example, that we would prefer them to access. So until those barriers are removed, I think we'll still continue to see some limitations from a literature review perspective. Has anyone else tried some of these deep research models? And if so, what has your experience been?
Hi, Adam. This is Andy. Can you hear me?
Yeah, go ahead.
So I haven't used these new models, but social scientist by background, and I'd done a lot of coding work early in my career. And I started to experiment maybe 5 or so years ago with natural language processing as an augment or a substitute to coding, and limited success, I would say there, but some of the success was in part because inter-rater reliability was so surprisingly low between humans that it was kind of it didn't have to be that good to start to compete with human coders. I don't know if there's been any examination of like some of those NLP or kind of more automated coding processes against some of these new techniques, or if that's just a completely different animal.
Yeah, I think that's sort of a different beast in and of itself. But, as part of the process in doing some of these experiments, we've sort of been asking what I thought initially was maybe a silly question, and that is, are the human raters the gold standard, right? Like, of course they're the gold standard. At least that's what we think of, right? But I don't know, the more I think about this, I think we need to actually prove in some ways that they are the gold standard. So in a lot of the work that we've done, we've taken just a small sample of raters, like 2 or 3 raters, right? And then we're comparing that against AI. Whereas maybe if we used a crowdsourcing technique of 2,000 raters on a single topic or rubric that they would use or whatever, maybe we would see a different outcome, right? Maybe that outcome would actually better mimic the outcome that we're seeing with AI. So I'm actually starting to rethink that question of, are humans the gold standard? And if so, to what extent do you have to prove that gold standard?
Yeah, Adam, I think that's a really insightful point, and I could see, I mean, because that was some of my lived experience. Was it wasn't really that one rater was correct or incorrect so much as that they had different life experiences, if you will, and the consensus process was actually developing. I would describe as a third understanding of the world that somehow bridged the two.
Yeah, exactly. So hopefully more to come on that. We'll dig into that literature a little bit just to learn more about crowdsourcing and how that might translate into the world of AI and whether or not there's some interesting insights we can learn from that.
So one last comment, then I'll be quiet. I just want to express again my deep appreciation for this series, and I think, Emily, you really made the case in terms of just how much change we've seen from January to April. So thanks everybody again.
You're welcome. Thanks for attending. All right, looks like we have about 4 minutes left. We're happy to stick around to answer additional questions. Emily, I think you had another slide for a quick note of feedback from the audience as well.
Yep. So first of all, I just want to take a minute to remind people of some upcoming events. On April 18th, the AI learning community is convening for discussion of generative AI for academic innovation with guest speaker Dr. Ben Rush from University of Wisconsin-Madison. If you're not a member of the AI learning community and want to learn more, feel free to reach out to me. And then keep the date in mind for our next AI workshop that will be on May 20th. And Peg, Checky, and I are going to talk about AI, social determinants of health, and equity focus. So that will be on May 20th. And lastly, I'd like to ask you to please consider giving us feedback on today's workshop. I'll also put a link in the chat to that forum. And let me know if you have trouble with this unwieldy URL that I just put in the chat. I'm going to stop the recording, but I